In C#, we deal with complex objects that sometimes have nested objects inside of them. In SQL, a query returns flat rows. Those two structures don't match up well. Entity Framework allows us to return complex objects, not just rows. But how do you do the same thing using Dapper? In this video, we will look at how to load order objects, each with a list of order details inside of them. We'll look at multiple ways to accomplish the task using Dapper, as well as how this can be much more efficient than the default method for loading these in Entity Framework. Now, before we dive in, I want to share a few things with you. First, if you're interested in improving your C# skills, be sure to subscribe to this channel. With over 500 C# videos and counting, it's the perfect place to learn and grow your skills. Second, if you're looking for more free resources, head on over to iamtimcorey.com and check out the resources tab. You'll find a podcast, the C# projects page, and much more. And third, if you're ready for a deeper dive into a specific C# topic, I have a variety of courses that can help. Not only will you receive a world-class education, but you'll also help fund my free content so that everyone can have a great education in C#, not just those who can afford it. So let's jump into the code, and I've already written the code for us. I'm not going to try and write this on video because there's a lot for what we're doing. So let's just look at what we have. Now, first off, I am using an SSDT project, which is a SQL Server data tools project. And what it allows us to do is write a database inside of a Visual Studio project that allows us to put into source control. It allows us to version all of our objects, our tables, our store procedures, and so on. And it allows us to publish to LocalDB or publish to any database during the CI/CD process. So this is a really helpful way of doing things. It also allows you then, when you get the source code, if you want it, which the source code link is in the description. If you get the source code, then you can have this and just run this publish, which you'll probably have to make some changes to for your case, but this gets you started. You just point it to the correct location. Mine is localDB/MS/SQL localDB. But when you publish and hit publish, what's going to happen is it's going to create for you a SQL Server database project. So in here, I have a database and I have my order DB. Inside of that, I have two tables. I have my order table, which we can, let's go view the code on this, and we'll view the code on the details as well. Let's load the details. Okay, so the order just asks for an ID, and then it has a purchase date and a total. We're keeping this super simple. We are not trying to make a complex thing here. So I've cut out a lot of things that would normally be in here. For example, on the order, there is a lot of details that aren't included. We're not even including things like, how many things they purchased, who purchased it, all that stuff. And then the order details, this is a one-to-many relationship. Notice we're asking for order ID that links up to the ID in the orders table. We're linking the order ID in the order details page. We're linking order ID to the ID, and we're just saying item price. There's no quantity. There's no nothing else. There's no tax, all that kind of stuff. We're just keeping it as simple as possible, just to have something that is this relationship of parent and multiple children. Okay, so let's look at what this would look like in the data. So if we look at order, go view data, and wait for that to load. We'll also view data on the detail as well. So the orders, I have 3 orders in here, and I just said that the date was, I picked 3 random dates, the 1st, the 15th, and the 18th of October. And the totals are 50, 150, and 115. Actually, I think this will be 110. These are not linked together. This is just, to keep things simple. Now, just so you know, when you create this database using this order DB, I did not script out these records. Therefore, you have to create them yourself manually. You can create whatever records you want. The data, I just put some stuff in here. So I linked up these two entries go to this first order, and then these three entries go to this next order, and then the rest of the entries go to this final order, okay? Super simple. I have some item names here as well as some prices, just to have some type of data here. That's all we're doing. Now, if we were to query just this table for C#, that'd be pretty simple, right? We have a model that have ID, purchase date, and total. Pretty simple. If we just query this table, that also be pretty simple. We have a model with an ID property, an order ID property, an item property, and a price property. But how do we have an order with a list or a set of these? Okay, so I've created that. So we have our order model, where we have our ID, date purchased, and total, and then a list of order detail model. So order detail, this is our order detail. We have an ID, an order ID, an item, and a price. Notice it kind of matches up with what we have in the order details table. So that's what we have for our objects, but how do we kind of populate that? Now I'm going to show you what, first of all, the default way. Now Entity Framework has new ways of doing this, but the default way Entity Framework would load this up. So let's do a new query. And I've already got it written. Again, trying to save some time here. This is essentially what Entity Framework would do. So select from the orders table, I just renamed it O, and then inner join on the order details table, OD, on O.ID. So the order ID equals the OD or details order ID. Link those two up together and return all the data from both tables. What does this look like in the return? So this is what it looks like. And as you can see, we have our ID, we have our purchase date, we have our total, we have the ID again, which that's the order ID. We have the order ID, that's the order details table ID. This is the order ID in the order details table, which matches up to the order identifier. And then we have our item and we have our price. Now, the keen item among you will notice something, and that is we have these two entries right here are duplicate. Actually, these right here are duplicated because we have two different entries here. And then this right here, we have three duplicates because we have three different child items. And then down here, we have 11 duplicates because we have 11 different items that are details that attach to one order. So the way Entity Framework does it is it returns these as rows. And that's pretty simple. You have a bunch of rows. You have 16 rows here for all of our data. But then what it does is it says, well, this is actually the same record, this data. And so it eliminates this one right here. And then down here, it eliminates these two because we already have this one. And then it eliminates down here all the rest of these because we have this one. So that's what it does in kind of the black box that is Entity Framework. And that's fine. I mean, that works. And when you have small to even medium-sized tables and a few joins, that's not really a problem. But what we're doing here is we're transmitting a whole bunch of extra information across the network. So we're transmitting this entry and these entries and these entries in duplicate. So that can be a lot of data. We've got a really simple example here, and yet we've got 10, 12, 13 duplicate records out of 16. So that can be a lot of extra data across the wire. Again, especially if you have, order with order details linked to people and linked to, a number of different joins. Now, there is a way to split query in Entity Framework now, which is a really good thing. It makes things a lot more efficient because it would do multiple queries. And we're going to see how to do that with Dapper ourselves and split the query ourselves. So that's kind of the easiest way for any type of ORM that needs to do it manually, need to do it itself, like without us intervening, this is how it does joins, okay? So we're not going to do that with Dapper. We're going to be more efficient because that's the whole point of Dapper, is to be more efficient in how we talk to SQL. Because the more efficient we can be, the more performant our application can be. And we also have the nice added feature of it works better with managing SQL and not trying to conflate both C# and SQL into one. Okay, so that's our query. That's the one way of doing things, but we're going to do things differently. And so what I have done, let's look at our data folder. Now I have a SQL data access. This is really standard stuff for for Dapper. And what I've done is I've said just have a load data async. I do have a save data just because I do a sync. I used GitHub Copilot to create this, and I think it probably took from my previous code because my demos have been out there for a long time, and so they've been in a number of different libraries on the internet. So I just pulled from them and generated pretty much this. So I tweaked a couple of things, but I just want to point out again before we keep going that this is a demo application. There's a lot of corners that I have cut in order to keep things simple. So for example, there's not error checking. I've avoided checking any errors because it just makes things more complex. There's no logging. And here, I'm just asking for the default connection string. So, you would really want to have this named and pass that name in so you can have more than one connection string to more than one database potentially. So, but we're keeping things simple. So all I'm doing here is doing an asynchronous query to the database with a store procedure. Okay, that's it. So this allows me to create this order data class. This is where the actual work gets done. So the SQL data access is all generic, but this is where the actual work gets done of talking to SQL. So let's collapse these other two down here. I've got, let's collapse them all. I have 3 different methods here to show off 3 different ways you can do this. I have the get order async, where actually, you know what? Let's move these around. I want to, there we go. I want to do this other one first. And that is the get orders async. That gets all the orders, all right? That's give me all the orders, all the stuff. This one gets a specific order based upon its ID, and then all the details for it. And this one gets orders based upon a date range. So this allows us to see how we would get data from 2 different tables efficiently in a way that does not require us to call the SQL Server lots of times. So, and by the way, just this is a Blazor project. We'll look at the results in a minute, how the page that displays these. So first up is the get orders async, which is going to get all the orders. So I load the data for this store procedure that just says get all. All right, so we come down here to orders get all, and it just says, here's the 3 columns from orders. That's very simple, get all. And then I say also another query here for the order details get all, which is this store procedure. Again, real simple, get all the order details. So now that I have those 2 queries in results, orders and details, I say for every order in the orders, loop through all of them. And the line items, which is, remember, that's the list of order detail model, line items. So in there, I say, give me all the details, that's the second query results, where the order ID equals ID. That's the matchup we saw in SQL, but we're doing it on the C# side. And we put that in the order items. And now we can return order, which is a list of order model. And each order model has 0 or more order details, actually 1 or more order details in them. So we just do 2 queries, not 1 query per order, just 2 queries total. and we do a join in C# like this. This is what the Entity Framework's split query does. So that's what we're doing. We're just exposing those, 4 lines of C# code. So that's one way of going about it. But then what if we decide we wanted to have only one order? Well, that's actually pretty simple because we can say get order by ID and pass in the ID. So get by ID, we pass in the ID and just say get all from the orders where the ID equals ID. Cool. But then how do you deal with the order details? Well, first we do a check to make sure we actually found an order, because if we didn't find an order, there's no reason to continue. But if we call the order details get order by ID, by order ID, I apologize. So get order details by order ID, where we do a lookup based upon the order ID, because we know that that's the match, right? So then we just say the line items is the details, that second list from SQL. So again, we call the query 2 queries and we're good to go. So that's pretty simple, but what if we have something more complex? For example, what if we have a date range? So I want all the orders within a date range. Okay, so we're going to call SP orders get by date, which is pretty standard. We're going to pass in a start and end date. And then, by the way, date time 2, that's important. Instead of date time is the old deprecated way of doing things. Date time 2 is the new way. It sounds bad to say date time 2, but the reality is they had to keep date time around for legacy purposes. Therefore, it's created date time 2. By the way, if you're kind of getting lost in the SQL stuff, I do have a new course out called Accelerate Microsoft SQL that's designed to teach you what you need to know to be a SQL developer in a weekend. So check that out. I'll link it down in the description. But what this is doing is passing in 2 dates, a start date and an end date. And we say select from orders where purchase date is between the start date and the end date. So that's pretty simple, right? The orders. But what about this order details get by date? Because order details does not have the date as well. So order details get by date. We're going to do a select. We're going to have an inner join. So we're joining on the ID, and we're saying the purchase date is between start date and end date. And then just give us the elements from the order details table. So we join the orders table, but we're not using anything except for in the where clause. So we linked them up and said, only give me the items that are between the start date and end date, but only give me the columns from the order details table. So we don't get duplicates here because we're only going to return the records from the order details table, which are all unique. Okay, so with that, we get the orders, and we get the order details, and we again do that matchup based upon the order ID. So we've done 2 queries, not a second query per order, 2 queries total. We return the orders. Let's see this in action to see the actual results of this. So I create a page here called orders. I use Blazor. Blazor is super fast to create things. It's getting even faster and easier. So this is how I create a lot of demos, just because it's super easy to use. This is Blazor Server. Again, it's even easier because of the fact it's a server-side language, even though it has a nice client-side interactivity. So I created 3 buttons here, one called Load All, one called Load One with an input for our ID number, and then one that has 2 inputs for dates, and then a load by date. All right, and we just show the results here. And there's the code behind for it: load all, load one, and load by date. Okay, that's all we're doing here. The only tricky bit is this one right here. We only get 1 record back from this get order async. So instead of trying to load that separately, since I have a list of order model, I just I add it to the list. That's all I'm doing. And I just check to make sure it's not null first. So let's run this and see it in action just to see that really it's not that hard to call complex objects in SQL using Dapper. Okay, so let's go to the orders. And in here, so we have load all, we have load one, we have load by date. Let's start with load all. And we have our order with gum and grass seed. We have our order with gum, charcoal, and coat. And we have our order with all the encyclopedia books through L. So there's all three orders. That's a load all. But I know that this one right here is order number 2. So I just put, again, there's no error checking here. That's okay. Load 1, order number 2, and it gives us just that one. If I load order number 3 instead, I'll get all the encyclopedias. If I load order 1, then I get just the gum and grass seed. Now, I can come over here and choose some dates. Let's choose a date of the 1st of October through the 7th of October. I get one thing back. Actually, it's the same thing. Let's change this up and let's go through the 17th. And load by date, we have 2, the 1st and the 15th. And if we go through the 19th, we can see all 3. If we change the start date to be the 17th, we only get the one on the 18th. So super easy to do this complex object in Dapper just using 2 queries. Okay, 1 per set of objects. So that the end result here is that we're just saying get the original list and then get the sub objects that match up to the object I got in the first call. So that's all there is to it, is just those 2 calls. Now, we could be a little bit more fancy if you wanted to. Dapper does allow us to return more than 1 record set. And I covered that in my advanced Dapper video here on this channel. But what we could do is we could return both of these record sets in one call, and then just get the data into 2 different lists and then do the matching there. But that adds a layer of complexity that I don't think is necessary here. Making 2 different separate calls is pretty efficient. It's very efficient. And it allows us to then call these separately if you want to, and not have to worry about getting extra data back that we don't want. That's the thing with SQL is we want to only get the data we want, and we only want to transfer the data across the network that we actually want or need. So that's how we can very efficiently talk to SQL Server and get the records we want. Now, what if we had multiple nested objects? For example, let's just make this up, but what if we had a person object who purchased this, and it's a person object? Well, then we could just do another query for just that person. And then if we had, that person object had addresses inside of it, of all the different addresses, well, we do another query that would be all the addresses that match the person object that match the order. So the only place that you should see any complexity at all is in this method that is in the order data table. This is where all the complexity should be living. It's where we say, okay, call SQL and get this data. Call SQL and get this data. Match the data up. All right. The end result is that on the front end, you should see things like this. Get orders by date, get order, and then you just have to add that to a list of, that's a little bit of complexity just because of the way the UI works in the front end. But we've got one-liners here. There's no complexity at this point. We've put all the complexity, which is not much, but in that get orders by date async, where we do the actual work of talking to the database, getting data back, and so on. Now, one of the questions that will come up is, hey, isn't it inefficient to call this database more than once? No, it's really not. It's designed to be very, very efficient. And this is the recommended way of doing things. However, if you really wanted to get that last little micron of performance, then in our SQL data access right here, we're opening up a connection to SQL, doing one query and closing it. That's super efficient. And we do have connection pooling. So there's some efficiencies there as well. But if you really, really, really wanted to, you could, put in here the multiple calls that we only have one connection to SQL that opens and closes instead of two that open and close. But again, I don't see that performance optimization as really saving you anything because of connection pooling. So that's not something I would recommend doing because it's not adding efficiency, it's just adding complexity. So don't just add complexity for non-existent or theoretical performance, all right? Make sure you wait to optimize until you realize there really is a problem. But we do not run this query inside a for each loop because that would be inefficient. Calling this once per record, if you have 1 million records, that'd be a lot of calls. But if you have 1 million records right now with this query, it'd still be 2 calls. That's it. And you might say, well, that's still a lot of data to put in memory. Absolutely it is. And that's something you have to think about is, do I really need this data? For example, if you just want to know what orders are made when, you don't need to get the details. You can just get the orders. Again, that's why having 2 separate store procedures is really helpful. Because that way you can just call this one and say, here's all the orders. And then if someone wants to see the details of a specific order, then you could call the this store procedure right here by order ID. You have the order ID, just say, I want the details for order ID number 2. And it would load just those details. So it's super efficient and you get the data only when you need it. The less data you have in memory, the better. And this is where saying, hey, I want to limit by some criteria instead of getting all the records is really important. Okay, so that's how you'd use Dapper to populate complex models that have nested even lists of models underneath it. All right, it's not hard. It's just making more than one query and doing so efficiently. Again, this source code is in the description down below. You can click it. You have to give me your email address and I'll email it to you. But that's there. And if you have any questions about SQL, again, I have that course that is designed to get you up to speed quickly on SQL in just a matter of a few hours of work. So I encourage you to check that out. All right. Thanks for watching. And as always, I am Tim Corey.